Hi everyone. So in the end, intentionally how we prepared it today is I will talk a little bit more about the architecture and general idea behind modern architectures around a data mesh, and then Nathan will do the second session from the Wix perspective about the real world experiences and also going much deeper into the technology than I do. So it's really a good mix of two talks. And the title, of course, is a little bit provoking intentionally, right? So it says the heart of the data mesh beats real time, which I think makes sense. But what I also want to be very clear before I even start with the presentation is that data mesh is an architecture principle, right? So it's not a product and not a technology. And so in the meantime, I hear a few vendors that tell you I can build a data mesh for you, and this is nonsense in my opinion. So it's not a single technology that can solve this problem. And so that's what I really want to point out. While I still think that sharing the data between the systems makes a lot of sense in real time. And so that's in the end part of the story I will talk about today. And you will also see a few case studies from our customers which have built a data mesh. Some even without knowing it because they started earlier and the data mesh term didn't exist at that time. So they still built microservices there. But that's another discussion. I will also talk about that a bit. And so I really travel around the world and see so many different deployments and architectures, and in the end, there's always trade-offs. So should everybody now build a data mesh? Frankly, many of the customers I meet now, they say, yes, they want to go that direction, but then when they realize the trade-offs, they say, yes, in general, but here still, maybe even a monolith is the better solution, right? Or buying a software product simply as one service, instead of using a lot of very micro services or even microservices, even smaller than that. And therefore, it's really a combination of different technologies. And so what I want to talk about is really also not just too much about these general principles. I think everybody has in the meantime heard about the general idea of the data mesh, right? Where we now focus on data products and we support cross-functional teams working with each other. And this all makes a lot of sense. What I see, however, often in the field, because when I meet customers, we sell products, right, with Confluent and Kafka, but we need to solve business problems, and then very often some people discuss too much about instead of doing things. And I'm more a fan of first doing things, and then also with that building the right architecture around that. And I think the mix is somewhere in the middle. So I won't even go into the theory here. So I really want to focus therefore on another picture which you maybe have not seen before. So when I talk to customers, and I don't just speak with developers and architects, but also a lot with executives and business people, and they typically ask me more about the business value of such an technology like Kafka or Confluent for data streaming, but then also about the principles behind new cutting-edge discussions like data mesh. And so what I really see why our customers are adopting the data mesh more and more is number one is time to market. The biggest problem I see, and I had 4 or 5 meetings yesterday here already in Tel Aviv. The main problem across all industries like insurance, banking, technology, it's always how can we roll out new features and solve business problems easily. And that's the biggest problems organizations have these days. They don't have the manpower. That's also why they go cloud first. But then to solve the business problems, they want to focus on a specific thing. And this is really where I see, like McKinsey defined it here, that the value, that time to market is so big with data mesh because you can't build your thing without focusing too much on what others are doing. You build your data product which solves a business problem. And with that really, how we also take a look at that is starting with the business problem first and defining what is the problem to solve, and based on that, how to build that. And then very often it's one or two of these data products in the overall architecture. And this is why when I show this slide to developers and architects, and many of you might agree, then they say, this is not a good architecture here because this doesn't make any sense. But McKinsey doesn't talk about architectures, right? So they are really talking on a high level about what's the value behind why people are doing something like a data mesh. And that's why I like this discussion point in the beginning, to think about it not just about the technology and best practices, which we will hear a lot about today, and especially then when Nathan from Wix is talking about that. But it's really also about what problem do we solve. And this is now where my title also comes into play. Why is Kafka so successful in the market? So in the meantime, over 100,000 organizations use Kafka worldwide. So more or less, there's not many bigger companies that are not using it. And the reason is what you can see at the top, right, in the slogan here. Like it says, real-time data beats slow data. And as I said, so I'm not just talking to the technical people, but really to the business and executives. And so what I also ask you, here in the room today, we have a lot of technical people typically, right? So when you talk to your business or product owner who needs to solve a problem, ask them like that. What's better for you to access data? Is it now or later? And if you think about that, I have not seen a business person that tells me it's better to get the data later. For some use cases, it's still good enough, no question, right? It's not saying Kafka can solve every problem, definitely not. That's why we combine it with other technologies. Like, if you need to create a fancy report every 24 hours for your CIO, then this is a report from a data warehouse, perfect for that. If you want to do machine learning model training, you take a look at a lot of historical data, and then you train a model for hours before you have the model to do predictions. That's a classical batch process which runs perfect in a data lake. But for the other use cases, and so many of them, and here's just a few examples across industries, think about that. Which of these use cases is better later than now? Most normal use cases are not. And then sometimes we have scenarios where real-time is comfortable or nice, like a personalization, a recommendation for you for upselling to a retailer. So that's nice, and you can increase the revenue a bit with that, and the customer experience is maybe better. So here it's nice to have in value, but not mandatory. On the other side, we have cases like, think about fraud detection. Fraud detection only makes sense in real time, because if you only analyze the payments in your data lake an hour later, well, you will still find out it was a fraud, but you find it out an hour later, it's too late. The fraud already happened, the money is gone. And with this, keep this discussion in mind, right? Why I said in the beginning, the heart of the data mesh beats real time. Because if you can share data in real time, you still have the choice to consume it in real time, batch, request, response, or whatever. But only if the heart is real time. If the heart is your data lake and you store it at rest, you can only query the data at rest with a SQL query or web service, and that's too late and for many use cases, or it doesn't scale well for millions of users. And this is the main motivation why we see this adoption of data streaming. And this is really a game changer. Like we see the cloud as the game changer for infrastructure. It's more elastic, it's scalable, you can scale up, scale down, time to market is much easier. In a similar way when we talk about data, and I just mentioned that. So in the last 10, 20, 30 years we learned that we store data in a database, or today in a data lake if it's big data. And then we query the data with a technology to do a request response call, and then we do analytics there. And that works for the use cases we have built in the last 20 years. But for today's requirements and innovative use cases, we need to process the data while it's in motion, while it's interesting. And this is what data streaming is. And this is the foundation of sharing data between the different data products. Because for the data products in the data mesh, it's the same discussion. If you shouldn't start this discussion with technology. Should I use Kafka for that, or the data lake, or the data warehouse? That's a great question, but it doesn't matter. The question is, what's the business problem? And if the business problem is, we want to build a data product to solve a problem, and this data product is recommendations, or it's fraud detection, or predictive maintenance, these are use cases where the business will tell you, of course, now is better than later for such a data product. And therefore, I really want to clarify on one slide in the end what we mean with data streaming, with Kafka, with Confluent, because I still see too many misconceptions here. And then when we talk about how to map this to a data mesh architecture, how we fit in or how we don't fit in, what can we do with Kafka and Confluent, what can we not do or should not do. And so I have one slide here for that. And this slide is a very common architecture, right? We have a Kafka streaming platform, we have legacy databases on-premise, we have applications on-premise or in the cloud, we have on the right side cloud-native databases, data warehouse, data lakes. We have stream processing engines, like here, maybe KSQL or Kafka Streams, or maybe you use another non-Kafka tool like Apache Flink for that. But in the end, you have a lot of different systems. And so where can data streaming help? So this is only possible to explain if you understand the fundamental components of data streaming. And this is where I see too many misconceptions still in the market. And honestly, even in our customer base, where people use sometimes Kafka for years already as an ingestion into BigQuery in a data lake. Still, they don't understand what other things you can do. And so this is really how I also explain, not just here in meetups or to technical people, but even to more like the executive people, like what is the components of the platform? And so the obvious part is the first one, which is real-time messaging. So that's why still people, I don't like that, but still many people compare Kafka to a message queue, like RabbitMQ or IBMMQ, which is in the end nonsense because it's apple and oranges. But still, the reason why Kafka is used as a real-time message layer is why people compare it like that. And the first difference, however, here is that Kafka is built for any scale. What most people here in the room typically know is, yes, it's built for big scale, right? So at LinkedIn, it was built for processing gigabytes per second. So that's what you can do. In Confluent Cloud, for example, we have customers that process 5 gigabyte and more, 10 gigabyte and more in a single cluster. You can't do that. Often you don't need that, but in a telco environment or in a gaming environment, you might do that. But that's the analytical use cases. On the other side, Kafka can also be used for transactional workloads. Since 2017, so now 6 years already, Kafka has a transaction API and exactly one semantics. So that works very different than what you might know from an IBM MQ system or Oracle database. It's very different kind of what a transaction means in the API. But in the end, the business goal, again, to the business problem, the goal is you send an event from a producer, like a mobile app, like a payment. You get it into a streaming platform, and you get it into your risk analytics system. You get it into your core banking platform and into a data lake. And you want to ensure that this transaction is consumed exactly once everywhere. And this is exactly what you can do with Kafka for 6 years already. And so keep that in mind. Kafka is not just for analytics, but our customers use us mainly for transactional systems. Payments, fraud, customer communication, everything where 24/7 is critical. And so now comes the second part, and this is the other thing which so many people underestimate. So Kafka is a storage system. So it's not a queue where you delete it from the queue after it's consumed. You keep the data, the events in Kafka, as long as you want to store them. And you can make a choice per topic, like if you have log data, you might only store it for a day. But if you have transactional data, you might store it for a month or a year, or retention time -1 forever. Why? Because then you can also replay historical data from the log in guaranteed ordering that's built into the system. But even if you just store it for a few days or weeks, the big benefit of the storage is that you handle the back pressure. Producers produce data. They don't ask if a consumer can handle that. And not every consumer can handle big load. And not every consumer is real time. And this back pressure handling is why a few years ago already, we didn't see many microservice architectures that did not use Kafka. And this is a bit the funny part here. So when we still go back to when microservice discussion started, I don't know, it was now 7 years ago, I think, when Martin Fowler started the discussion, right? And like today, data mesh, everybody talked about microservices. And the funny thing is that at that time, all the papers talked about REST and web APIs, right? Today, if you take a look at microservice architectures, it's always based on Kafka. So why is that? It's because Kafka enables true decoupling between the systems. That's very different from direct request response and synchronous communication between each other. Point-to-point spaghetti code. And that's the big game changer, and that's why Kafka today in the deployments I see, probably, I don't have official numbers, right, but probably 80–90% of deployments I see are not about big data. Kafka is used for all these transactional architectures where you build microservice with independent systems. And a microservice, that's a definition, right? It can be anything, a Java application, Spring Boot, it can be an Oracle database, it can still be a monolith, doesn't matter. But they are connected via Kafka and still decoupled. They can be their own thing, their own technology. And now the most important part for me here for this discussion, it can also be its own communication paradigm. Not everything is streaming, not everything is real time. So yes, you can also connect to a message queue like RabbitMQ with connectors. But on the other side, you can also provide an API to connect via request response to the data. And also with batch, FTP, right? All of that can be shared. But the heart, and this is again the data mesh, the heart beats real time, that's the Kafka and why it's so different. At any scale, reliably. And then you can do more around that, like data integration. So you can use another ETL tool, but you can also do the integration with Kafka in many cases, with Kafka Connect. You can do the data correlation, the processing, so-called stream processing. You can do that with Kafka Streams Java, with KSQL, SQL code. You can do that with a third-party thing, not Kafka like Apache Flink. But this is stream processing. This is super powerful. And this is typically the secret sauce in most architectures. Because while most customers start with a pipeline, they build a pipeline from Oracle, they ingest it via Kafka into Google BigQuery. That's a great first pipeline. It's already value, and it's relatively easy to build. But the secret sauce and the business value is when you're not just building pipelines into other batch systems, but when you take the data from these different systems and correlate it in real time. And this is the stream processing part of Kafka. Or in addition with different other tools like Flink. But the end-to-end pipeline then is data in motion. And this is the paradigm shift for building these kind of applications. And then you have more on top of that, right? Like in the cloud, it's fully managed. That's critical there. You can focus on the business logic instead of the infrastructure. This is one of the main reasons why people go to the cloud with all their services. And the other point, however, and this is also important regarding this data mesh discussion. So where sits your data product? Well, if you go into a large organization, it's everywhere. Most of our big customers, they are hybrid. They still have a lot of on-prem stuff. They go to one cloud, another team goes to another cloud, and then they are spread across continents anyway, because some business is in Germany, some is in China. China has only Alibaba Cloud, right? So it's spread across all the different things. But that's fine in a data mesh, depending on how you take a look at that. But even here, the sharing between these systems, that can be done with many technologies, of course. Every database, every data lake also has replication capabilities. But with Kafka, you do the replication in real time. So the next downstream application in China can decide by themselves. And the business should decide, do I want to get it in real time? Or do I want to get it later in the data lake for my report? You have the choice. If you first put it on disk here and replicate it to China, well, it's at rest. You cannot connect a real-time consumer in China to that. And therefore, how I typically define a data mesh, and I'm actually not super happy with the term that is used so much these days, because in my opinion, in the end, it's combining other different paradigms that exist for a long time, right? And it's reusing them, which is fine, right? Now we have a new hype about a new buzzword. But in the end, what we are trying to do for so many years already is building domain-driven design so that the different business units can do their own stuff with their own technology. Then this was more or less also used as the term microservice. Even so often still a monolith might be a better solution for a problem. And now we are more or less combining all these things together with event or data streaming so that we do a little bit more real time here instead of just sharing data in batch. But this is how I typically define a data mesh. But everybody probably agrees. If everybody defines the term, you would all have a different definition. So also make clear to define what you mean with that. But that's in the end my definition here for the rest of the talk. When I talk about data mesh, the main idea is that different business domains can solve business problems, choose their own technologies, solve the problem, but still share data with others because they need some of the data to share their own business problems. And now two more very fundamental things, and then I will go a little bit deeper into the data product and how people build it. But the main difference really, if you build a data mesh, or in general a good enterprise architecture around data streaming, is that it's not like this, where you put all these systems and glue them together, but in the end the main goal is put everything into one data store at rest. Because again, then it's at rest, it's stored there. It's great for reporting, for some analytics, for model training, but you cannot connect a real-time consumer to that thing here because it's already at rest. And so it sometimes amazes me, right, when I've seen a lot of talks around Apache Spark, where Spark also has Spark streaming, right, where you can do stream processing. But in all these kind of success stories I've seen so far, the first initial point about they started the stream processing was connecting to an S3 object store to consume the data for the stream processing. And that's not the right way, right? That's an anti-pattern, because then it's already on disk. First, you should process it. And then you can still store it on disk for the analytics part, but you should process it while it's in motion. And that's not what you do in a data lake. And therefore, this is the difference with the streaming platform, right? You still use data lakes and warehouses, but the heart, again, is real-time and scalable, and it decouples the systems. And then each data product or business domain can choose whatever they want. And maybe today they have a batch data warehouse, and tomorrow the business decides, well, we go more cloud native and maybe a new, more near real-time data warehouse. You're very flexible in your domain how to do that. And therefore, if we now think about building such a data mesh in a more decentralized way, where it's more decoupled, so there's in the end two options here. So what I'm talking about in this talk, right, like on this picture, is the streaming platform around Kafka, right, where you decouple things and you physically move the data, so that each business unit is independent on their own data products. But it can also operate and run even if other data products are down, because you replicate the relevant data and consume it in other systems. There is one other approach, which it's actually not something new, which is called data virtualization. This is a little bit more a trick, I would say, because here You just write a data product, and the data product does a query, and this virtualization layer then gets access to all these other databases or data lakes and consumes data, and then you have your information here. This often is used if you really have a quick win, because a business analyst can write a query and it's spread out across all the databases, and you get your information back and correlate it. This works for 1 or 2 queries, right? But this is not a clean enterprise architecture where you separate the concerns and the responsibility. So both are okay, but they're for very different use cases. And this is also what people often underestimate, especially when they look around products that are doing this here. And the last point I want to make here is then, now we talk about this kind of the heart of the data mesh beats real time. So still, in most enterprises where I talk to customers, most people still have a Lambda architecture. I guess most people are familiar with that term, right? So in the end, and we all learned this from Cloudera and Hortonworks maybe 5-7 years ago. So everybody builds a Lambda architecture. So in the end, you have a speed layer or real-time layer. This is in 99% Kafka, and then you have a batch layer. In the beginning, it was Hadoop, and then it was Hadoop and Spark, and today it's something in the cloud like Databricks or something else. So the problem is that reality on the right side, where you build your applications, again, to solve business problems in your data product, in most cases, you actually need both. You need some real-time data, but you need to correlate it again with some historical data to take action on that. Because, example, fraud detection, the real-time information comes in here, right, about a payment. But to detect if it is fraud, you need to correlate it with historical data. So you need to merge it together again. And therefore, the serving layer is the complexity, and then you still have 2 separate systems, real-time ingestion and batch ingestion. Another approach was, well, let's not build a serving layer, right? So let's just use a speed layer and a batch layer. Well, that's very smart, but then in the end, the serving layer, the migration is done here in the application where you merge it together. So it's the same story. And so what we see actually coming up more and more, and when I travel around the world at customers, even at traditional companies like banks, for example, is that more and more people, while not often using the name Kappa architecture, they're building one. Because they realize instead of building separate integration layers for batch and real-time, they just build a real-time layer for the integration. And because Kafka is not a message queue but also stores the data, it's still decoupled. And so your real-time consumer consumes the data in real-time, and the batch consumer consumes it in batch. You still can do all these things you did before, but you only have one infrastructure in the middle. And this is, again, the heart, which is real-time and scalable. Still, it supports batch and all these other platforms, but it's only one layer here. And what I recommend here is really, if you've not seen a lot of that before, there's plenty of practical examples in the meantime for that. This is the one I have here in this presentation because it has the best picture, I think. Here you see how it looks like, right, at Uber. So Uber has Kafka as its central platform here for the data hub. And then on the one side, they integrate with all the apps, right? The rider apps, the driver apps, API services. All of that is getting in real time at any scale, millions of users into Kafka. And then it's processed in real time for some use cases like estimated time of arrival, estimated cost, optimized routing while the car is driving, fraud detection during the payment. While you're getting out of the car, within 1 second, the payment is done. So all these use cases only work very well because their heart is data streaming, which is a combination of 3 things: real-time, reliable 24/7, and scalable. And this combination is needed for so many of these innovative use cases. Especially here, right in Tel Aviv, there's so many startups building these new things. On the other side, however, and this is the interesting part, you see here at Uber, so even as a data source, there's of course also some traditional workloads getting data in, like from databases like MySQL or Cassandra databases. And very often then you use principles like change data capture, so that even if this is a database, you push changes in real time into Kafka. The benefit of change data capture is you automatically get out of static data back into the eventing system because it's automatically an event that is pushed in here. And then you can use that in real time together with other data. Or, and this is the other part, right, you still have batch, of course. In the case of Uber, they're a heavy user of Hadoop still for their batch workloads. But Hadoop is still also consuming from Kafka. Why is that possible? Because Kafka is not just a real-time layer, but also a storage layer, append-only commit log. You append the data that's coming in here from any system. You consume it here in real time or near real time. But you also replay historical data later. And this can mean a batch every minute, or it could be a Python Jupyter notebook from a data scientist that's only run once a day and replays historical data from the last day or last month. So each data product, once again, is independent from the others. And there's more examples like this. So if you're interested in that, at the past Kafka Summit, so other examples I remember is, for example, Shopify talked about their Kappa architecture. Twitter talked about it. But also, for example, more traditional companies like Disney, for example. So at Disney, and this is, by the way, one of the best talks. So this is not all good, right? There's also challenges. It's always with trade-offs. And Disney did a very good job in also not just talking about the benefits like I did here, but also a few of the trade-offs they had. Because sometimes still a direct batch integration might be an easier way for some use cases. So and with that now, how does that discussion fit into the data mesh here? So here's a logical view of a data mesh. So this is not physical. It doesn't matter where it's deployed or how many clusters and so on. But this is, again, the idea of the data sharing, the data mesh. You build your own data products in a domain. So one domain can have more data products, and they share data with each other. So sometimes you have one domain. So in this case, from a Kafka perspective, this could be a shared service, where you have very different producers and different consumers, but within one business unit, they run their own Kafka cluster. And all these kind of requirements you have there from a data mesh perspective, like access control, like audit logs, like encryption where needed, and only sharing the right data with others, all that is what you need as part of such a platform with the governance on top of that. But then you can also share data with others. And again, here it's a logical picture, but this could also be another Kafka cluster. Maybe it's a different business unit. Maybe it's even one on another continent, like the one is in Germany, the other one is in Alibaba Cloud. And you replicate some of the data with the others because they need it here. And again, same story. I repeat myself here, I know, but you could do such a data sharing also on the database or data lake level, but there it's at rest. And here it's in real time. Still, one of the data products might be a data lake or a data warehouse. That's totally fine. And that's why we also work with all of these vendors together for the strategic partnership and integration between these different technologies. But that's in the end what you need to keep in mind here for building a data mesh. And here's another perspective on that. So I'm emphasizing this so much because I see too often that people simply don't really get it. So even though Kafka is real-time in the middle, right? You communicate with many different kind of communication protocols or paradigms. Like, yes, ideally everything is real time, but reality is it's not. So you also have RPC calls, like via REST API or gRPC or whatever. Or you even use a third-party tool, like your favorite ETL tool, and combine that with Kafka. There's a good reason why every single ETL tool in the market has a Kafka connector in both directions today. You will probably not find one which does not have a Kafka connector. Yeah, and also in the same way, right, you can integrate with other message queues. Like some time ago, people talked too much about replacing message queues with Kafka. I mean, you can do that, right? And sometimes it's more, from a license perspective, it makes sense. Like you could deploy 1,000 MQ brokers with one Kafka cluster. And that's millions of dollars sometimes. But very often it's more about integration, because this old data product that exists already for 10 years and runs the core banking under the hood with a mainframe, that's totally fine. So then you cannot replace that in half a year. Instead, you connect that old system via IBM MQ to Kafka, and from here you get the event from the mainframe via MQ to Kafka once, and then it's stored in Kafka, and then you can use it with other applications somewhere else. They are completely decoupled and independent. Just because you use a mainframe and IBM MQ for your core banking doesn't mean you cannot innovate in the cloud with completely new technologies, but still using the same data in both directions. And here's a practical example for that. So, we are also sharing the slides afterwards, right? Because what my favorite is always the case studies where end users are doing that. That's also like in the presentation from Wix afterwards. Here's an example from the Otto Group, which is a big retailer, and they have over 100 online stores worldwide. They're coming from the brick and mortar business, right? And in Germany, they're pretty big. And until 10 years ago or so, we ordered on the catalog. So we still got the paper catalog that big. And this changed, of course. But what I liked here, and this is again more like as a reference if you want to read more from a real world example, about what I talked about on the other slides is what they build in the real world. So they build a data mesh and what they call the event exchange platform. And you see the interesting characteristics are here on the right side, right? So of course it's real-time, scalable, blah, blah, blah. But more interesting and more challenging is things like multi-cloud and GDPR compliant. And then there's the data exchanges because the different domains or business units, they still do their own stuff. And they're under huge pressure these days to innovate. Like in Germany, where the headquarters are, there are things like Zalando, for example. And of course, Amazon is very big. So the reason why they are still in these markets is because they can roll out new features and services in their own data products very quickly. What technologies do they use there? I have no idea. But what I know is that they don't build everything. Sometimes they still buy a product as a service. For example, a cloud product for a marketing campaign. But they can integrate it easily because they're all decoupled then. And so this is really a cool success story about a retailer that went that way. Not just in the cloud to be more elastic, but also into the data mesh principle for the time to market. That's the main reason why they do it like that. Yeah?
When you mentioned Uber before, so why they choose to use Flink, Apache Flink, and not Kafka Story?
I mean, I cannot now speak specifically about Uber here, but in general, first of all, there's not always just one service which can solve a problem, right? And in stream processing now, I would say the leading systems these days are Kafka Streams and are Apache Flink, right? And then there's a lot of proprietary stuff. We also have KSQL for that, but the two major ones are Kafka Streams and Flink. And there's always trade-offs between these systems. And the good thing, and that's the benefit, I don't know about Uber here specifically, but in general, per business unit or data product, you can choose the right one here. Of course, in a company, you shouldn't use 10 different ones, right? Like with Apache Storm and I don't know what else. But you should choose the right 2 or 3 different ones and then pick your one for the use case. And I cannot talk about Uber, but in general, why do people use Flink a lot? So what I see, and that's my personal experience, the biggest benefit with Flink is it's natively built for streaming data, but it's also unified for batch. And so with one platform, the heart is event-based, but it's out-of-the-box APIs for batch processing. And this is typically what I see, one of the reasons why people use Apache Flink a lot. The other reason I see it a lot is also that in the end, it has a lot of good APIs, right? So the core is Java. That's what most people use today. But more and more people also use Flink SQL so that they write SQL queries for stream processing. Or also, and that's what I personally like a lot, they have a good integration with Python so that you can even attract data science teams to do data engineering with Flink. And so these are typically the reasons I see. And this is, by the way, so a great question, right? So maybe you have heard that Confluent acquired a company called Immerok around 2 or 3 months ago. Immerok was a startup that built a Flink service. So this is just now a side note, right, for the people who haven't heard that. So Confluent is also heavily investing into Flink and will build that into its future product. Because we also, like the market, see that Flink really is adoption is crazy. More and more people use it for different reasons because it's so that's the other good point. For everybody who said it's very complicated. And that's the great thing why it's good for a cloud service, right? So because in a cloud service like Kafka, and Flink is as complex to deploy. Because if you think about it, stream processing in general, the stories I tell you is great success, right? But building that is hard. And why is it hard? First, because it's a paradigm shift. It's not just a database and web service anymore, but it's continuous correlations. Very different programming model, right? You need to understand that. And second, especially when you build stateful applications, which are the real power, it gets hard to operate, memory issues, how do you scale it, how do you write the queries, what's anti-patterns, and operating that at scale in a cluster, that's what you see at Uber, that's what you see at Netflix, that's what you see at a few companies. But the normal company, it's too hard for them. And this is again, so we will build Flink for 2 reasons. The same for Kafka. It has great use cases, and it's also hard to operate. So the cloud service is the perfect solution because then you can focus on the business problems and use the cloud service. And now where Confluent has over 5,000 customers already in the cloud, I mean, what's better than just have one more SQL interface and write Flink applications fully managed against that, right? So that's in the end the idea behind that. But
and why you can use in Kafka storage S3 that is reliable, scalable, and cheap?
So say that again, the question?
If I use, I'm using AWS.
Mm-hmm.
So it's like a really cheap, scalable, reliable. I have a fully managed Amazon cluster. So why I will choose
And not S3 storage instead. You mean S3 storage instead of storing in Kafka. So typically, you do both, right? I mean, again, so Kafka, the goal of Kafka is not to replace database use cases, right? So that's very important to understand. I wrote a long blog about that 2 years ago. Is Kafka a database? The short answer is yes, because it's durable, it's persistent, you can query it, but, and the list is long, you cannot do complex queries against it. That's the main reason. And so you shouldn't think about using Kafka instead of an object store like S3, for example. But for some use cases, and again, not for all, but for some use cases, it's very valuable. If you have the ingestion anyway via Kafka from these systems, it's a guaranteed ordered log, append only. And you need to replay historical data from that order, right? That's perfect, it's built in. If you store all your data in an S3 object store, how do you get the data from the specific customer in that order here again, right? This is sometimes where it's easier from Kafka. And now this is again one of these differences, like with open source Kafka, storing big data in here doesn't make sense anyway, because it doesn't scale well, because rebalancing is a problem then. And the second problem is it's not cost efficient, because Kafka is using disks under the hood, so it's not using object stores. And so you shouldn't store terabytes or petabytes under Kafka. It doesn't work for that. It was never built for that. Having said that, with Confluent, we have built a separation between compute and storage. So like you do that by yourself with S3, with tiered storage and Confluent, both in the cloud or on-prem, we separate compute from storage and store most of the data also in an object store like S3. And with that, you can store it long-term, still in a cost-efficient way, because it's the same storage like in your data lake. But still, you can replay it like here in a log with the benefits of that. And in some cases, you don't even need another data lake. But to be very clear here, if you have very complex analytics and like model training, then probably a data lake here is the right option to get it through here, right? For your data product. Even so the data product then is a big data lake, that's fine for me. But if then you have another use case, and we've seen it in the field, where many people use Kafka a lot, and then they have a data science team that wants to access some of the data. And then they thought about just creating a new data lake with Databricks for doing a little bit of Python analytics there. And in that case then, if that's the data product for the data science team, well, why build another data lake just for that use case if you directly can use your Python consumer and consume the data from Kafka, right? And these are then the questions where it's a bit nuanced, but in 90% of use cases, it's still the data lake is the better choice with S3, but for 10%, you shouldn't do that. 5 minutes. Yeah, and with that, it's great questions, by the way, right? So I like it if it's more interactive. So, but with that, I just want to emphasize two more things. The one is, which I said a lot already, when we talk about these data products, what is a data product? I mean, this is different for every product then, because you use different technologies, you use different integration like streaming, APIs, batch. That's not the point. And let me get here. So in the end, each data product is its own technologies, right? That's why it can be connected to MongoDB, connected to S3 or whatever, or use another product that you buy or software as a service. That doesn't matter. Each product is its own. That's the great thing here. And the other point, we talked about that, right? What we're doing a lot is we deploy, depending on the scenario, also globally or across different environments, multi-cloud, hybrid. So this is really also what you need to keep in mind. And this is more like also a best practice or maybe a warning when you want to build your data mesh architecture or any other architecture with Kafka. I've seen too many customers that didn't start with the business problem. And so what you do then is, I build a mission-critical Kafka system, and then somehow they build disaster recovery in there, whatever that means for them. But if you don't define your SLAs and criticality first, then it's super hard to define the right architecture, because the problem is Kafka doesn't have just one architecture. And here's a few examples in the different colors, right? I just want to emphasize the most critical one. For me, the most interesting one are the critical ones. Like in orange, we have one here. This is what we call multi-region clusters. This is a single Kafka cluster which we stretch across regions. So we released that product 2 years ago with multi-region clusters, where we can stretch a single cluster across US West, Central, and East, across thousands of kilometers. Why do we do that? Because banks tell us that's a mission-critical use case. From a compliance and legal perspective, a bank needs to guarantee that they have zero data loss and zero downtime, even if a disaster happens in a data center. And so you see there's many architectures, but how do you find the right one? Define the SLAs first for your use case, the requirements. Too many people start with thinking the architectures without thinking about the business problem to solve. And with that, I want to show you one more thing to end the session. As you see, I have a lot of content, but I want to share you one more case study to conclude this. Because again, so this is what really matters, right? When you see how end users do that. And this is Raiffeisen Bank International. It's a bank which operates across many European countries. And the interesting thing here is they presented this last year at one of our events. They presented how they build a data mesh without knowing it, because at the time they started, the term data mesh didn't exist. But what they are doing by definition, when you see their slides and presentation, it's all these characteristics that you see in a data mesh definition today. So they have all their different domains. In their domain, in their case, the domains are even independent countries, right? Because each country has their own core banking platform, has their own CRM system. They need to glue these things together and innovate. That's what we discussed today, why they use Kafka for many use cases, also for the integration. But then they also replicate data to the central headquarters in Vienna, where they use aggregated use cases, where they need data from different countries. So they build very different data products. And what I didn't cover too much today is all these things around that, like data governance. So they have built an even taxonomy group-wide standard for their schemas and contracts, so that different groups can speak with each other. So that's a fundamental part of such data sharing, that you agree on that. And then on top of that, the security and compliance. So this is also, the recording of that is available. So this is really something which is really interesting if you want to dig deeper into how a customer did that and why they built a data mesh, including solving not just the data sharing and connecting to other banking platforms and databases, but also the level on top of that, the security and governance, which is a key pillar which is super important. And last but not least, about this story here, as I said, so they're running in different countries. Some are running in the cloud already with Confluent Cloud. Some others are running on-premise because some countries in Eastern Europe don't have a cloud. So they had a critical event last year. So last year in Ukraine, the war started. And Ukraine is one of the biggest businesses of RBI. So, and this is really, while the war itself is horrible, of course, this is a perfect use case where you see how time to market is crucial. Like most businesses, time to market is crucial to innovate and increase revenue. In this case, it's about the existence of the company, and even more than that, the existence of the people, because they need to use the ATMs there to get the money. And so, as you see the quote here, so the CTO of RBI said, we did this migration in 3 months because we didn't have a choice. And what they did is, they had to migrate all their IT infrastructure on-premise in Ukraine, 1,000 servers, into the cloud within 3 months, because otherwise they didn't know if they can continue something there, depending on how the war goes. And this is something also where they used not just Confluent for moving from Confluent on-prem into Confluent Cloud, but they also used all these replication technologies we have for doing these migrations, for the Kafka part, but also for migrating other applications from on-prem to the cloud. So a big thing about data streaming is not just data integration and sharing continuously between SAP on-prem and the Snowflake Cloud, but also for such a migration scenario, which we can also do without downtime.
Okay, so I'm using Kafka also. I'm working in Optimize, and also working with banking, and we are providing a cloud platform. But you mentioned before that Kafka Cloud, so it works with multi-cloud, and bank it's like the most secure.
Mm-hmm.
So
yeah.
How can you separate the data in multi-cloud like GCP, Azure?
Yep.
How it's working?
So that's exactly these questions, right, where it's not just about Kafka anymore, but a lot about security and governance. And this is what in the past 5-6 years our customers often built by themselves. And they're not running their complete core banking across multiple clouds, right? That's not happening. But still they share data between these infrastructures. But still you need to guarantee access, you need to have security encryption, often only on attribute level, you need to follow the governance, you need to do event tracing, all these principles on top. Well, and how did they do it? Well, that's also where we then have the products on top of that, so that the customer doesn't have to build that, right? So that's why one of the differentiators, what I explained, is we are everywhere. Another one is we are complete. So this is in our business model behind that and how our customers do it. But absolutely, so it's super hard to do that. But these are the questions often we help the customers with to answer them. But I mean, in banking, it's PCI compliance, right? All these things. So that's really critical. And with that, my last slide. So typically what I present is really how our customers have a journey for event streaming maturity. They start small with open source Kafka, they go mission critical, then they connect more systems, then they go global or hybrid and so on. In this way, this is the same picture now, but this is more from the data mesh journey, right? Where you have early interest, and then you divide the data, you have your own domains, you establish self-services and automation for that, and then you build more domains and identify operation self-service is completed or not. Federated data governance across the different domains is critical from a governance and legal perspective. And so you go more and more into this perspective, where, as I said in the beginning, often then the data mesh beats in real time. But still, of course, you combine it with all these other technologies like warehouses and data lakes, of course. And this is back to the question, this is actually my last slide really, what we are doing, right? Product strategy. We are not just doing the open source, we are doing a complete car instead of the car engine. And in the cloud, it's a self-driving car. So that's the only, in the end, marketing slide I have here, where you see that in the end, our business model is delivering data streaming as a product, as a technical product. Yeah, and that's it. I think we're at the end of the time. So I think we will directly hand over to Nathan as the second speaker. Or two more minutes for question, yeah? So any other questions on that? Yeah?
You talked about the RBI case, and the idea hit me that it should be extremely difficult for a company who started using that data in motion as a service to migrate to any other data in motion as a service provider.
Yeah.
What do you think about it?
Yeah. So the question in the end is, for such a bank, right, with operating on a lot of legacy and core banking, now they need to think data in motion, and that's super hard. And how do they do that, right? So the short answer is, and this is the tricky part here, or the good part, this doesn't mean that everything is now real time or in motion, but many of our customers start with simple use cases, like connecting Oracle database on-prem and IBM, connect that to Kafka, and from there, get it into Snowflake. So this is not really data in motion, right? Because it's still a storage system. You get it out of there into Kafka, and then you get it into another analytical system. Kafka is used because it's reliable, because it decouples, because it scales. And still, even in such a data warehouse example, even if you just improve data warehouse ingestion from a batch workload that takes hours into a near real-time ingestion that takes minutes, that's already a big business value. And this is actually how normally these kind of companies start with. And then the real data in motion, the stream processing, that's typically not the first step, it's not the second, it's the third, fourth, or fifth step when they do the stream processing. So the success stories you see here, like Uber, right? That's level 5 in our maturity model, right? So that's at the top. That's these extreme examples we can show. But most companies start here very small with very simple pipelines. And then they do a little bit of stream processing, often just streaming ETL transformations before they build real innovative applications, right? So it's super challenging. And therefore, that's why also we help early in the opportunity to do it right from the beginning with finding the right use cases. One more question, yeah?
Just a very quick one. What is the main list of your major competitors?
List of competitors. Well, in the end, I can tell you that our biggest competitor is Kafka open source. Because people do it themselves, right? Because they don't take a look at how much operations cost, which they underestimate when they need 5 engineers on that, and it's more expensive than the cloud offering already. And then the SLAs and risk if it's down, because often they only call us when it's down, and then they want to sign a contract after a day. But besides that, obviously, I mean, I joined Confluent 6 years ago. 6 years ago, nobody knew what Kafka is in the end outside of Silicon Valley. At that time, there was no other Kafka vendors, and we didn't have a product or cloud service. We just sold Kafka support. Today, it's very obvious. So the main competitors are the other Kafka vendors, right? Pulsar not really, because it's too late for Pulsar, right? To be very, I mean, I don't see it in the market, honestly.
Sorry for interrupting.
Yeah.
What about these PubSub, for example?
Yeah, that's the other point, right? So on the one side, I want to say the Kafka offerings, like the other ones, like Red Hat, Cloudera, TIBCO, IBM, Amazon MSK, whatever, right? That's the one kind of competition. The other one is then the other next generation, whatever, right? Pulsar, Red Panda, which I think we will see. I don't see them today. And then there is these other ones like PubSub, Amazon Kinesis, and so on, right? The big difference here is these kind of use cases are typically for one ingestion use case. Like when you want to get data from one system to another, or something like Kinesis might be good for that. What we are talking about, and that's why it's a perfect example for the strategic data mesh architecture. You wouldn't put Kinesis in the middle of this architecture. It doesn't make sense, and PubSub, because there's so many things around that. You need to connect to many different systems. If you use PubSub, then you need to use another middleware in addition to that. And where do you store the data longer than 3 days? right? You do not do that in PubSub because there you typically in these cloud services have limitations like storage no longer than 7 days or in Kinesis. And that's why it depends on the use case you look at. Sometimes it's more like the Kinesis and PubSub stuff. But for the strategic or more integration-like projects, it's typically either other Kafka services. Sometimes it's other middleware, right? Like the traditional middleware players, integration platform as a service, open source. So there's so many for so many things. You can solve so many problems with many different platforms. So it's a lot of different competition. It always depends on the scenario. Okay, so we are end of time. So thanks a lot and have fun with the next session.